So we're going to be talking about functions in Unit 3, and today's just kind of an introduction to what functions are. So we're going to talk today about, what is a function, and also every time you learn a new idea in math, there's new symbols that go with it, some new notation. So we'll talk about what a function is and what the notation is. We'll also you guys should be able to look at a table of data or a graph and tell me, does that represent a function or not? So that's our second topic. And then we're going to look at two other things called evaluating and solving. We'll see if we get through it all today. I'm not sure, but that's the goal. If we don't, then we'll finish it up another day. But that being said, let's begin here. So I put a picture of a guy here smooching a girl. So let me explain why. We'll call this guy. We'll call him Mr. Y, and we'll call her Miss X. Okay? And so this guy really loves Miss X. And so he's going to make a promise to her. Okay? And that's what you do in relationships, right? You make promises about how you're going to treat each other and right? So now this is math. So he makes a really strange promise to her. But here's his promise. He says, sweetheart, no matter what you are, I'll always be twice that plus 3. And he's going to keep his promise to her. Okay? So we have a relationship between Miss X and Mr. Y here. Whatever she chooses to be, he'll double it plus 3. That rhymes. Beautiful. It's like poetry. So like she says, really? What if today I'm feeling 5-ish? What if today I'm feeling 5-ish? Then he says, honey, I'll always be faithful to you. I promise I'll be 13 that day. I promise. I'll always double what you are plus 3. And she says, but what if like I'm having a bad day? What if I'm feeling a little bit negative? Let's say I'm feeling like maybe a -3 that day. What's he going to do to keep his promise? He's going to double it and add 3. So what's he going to be? -2. Let's see. Negative 3. Yeah, there we go. So if he's faithful, he's always going to keep his promise. Whenever you keep your promises, you know what we call that? In a relationship, we call that a functional relationship. Have you ever heard of dysfunctional relationship? I'm just being silly here, but I hope it kind of makes sense of this whole thing for you. Now, if it's a functional relationship, these two folks are going to get married. All right? And when they get married, they get a symbol to show that they're married. What's a symbol to show that you're married? A ring. That's kind of what we do over here in our culture. I think in India they have like a thing called a bendi. It's like a jewel that they put on their forehead. But yeah, there's a symbol to show, hey, I'm married now, right? Well, here's the symbol that functions use. Math uses whenever you have two variables that are committed to each other in a relationship like this. Instead of doing that, this is its wedding ring. It replaces the y with that. Now I want you to understand the f of x is still y. It's just that that's the wedding ring that it wears to show that this is not just any old relationship now. This is a functional relationship where y always keeps its promise to the x. Okay, and so that's what that's my cute little story for you guys to help you understand what functions are. Okay, so let me get out of the story now and bring it back to just plain math. Okay, what is a function? A function is when two variables are related to each other in such a way that whenever you have an input, you always get one output that goes with it. And whenever you have that kind of functional relationship between those variables, it's no longer just an equation, but it's a function, and we give it that symbol to represent it. Okay? So that's what a function is. So let's look at our notes then. A function is a relationship between two variables. Now, one of those variables is called the input, and the other variable is called the output. For each x you plug in, you should only get one y. And you see, Mr. Y would not be very faithful if when she was -3, if he was anything except what we got, I think it was -3 also. So if he was like, yeah, but I'm going to be 2 today, well, he's not keeping his promise, right? And so for each x that you pick, you should only get one answer out of it, okay? So there's an example of a functional relationship. Now, if an equation with 2 variables is a function, then we can replace the output variable, which is y. You can replace the output variable with the symbol f of x, as I've already mentioned. Is there anything else on here? And just so you guys know, we could use other letters. It doesn't have to always be f of x. It could be g of x. Sometimes we're talking about multiple functions at once. And because of that, they need different names. You can't call them all f of x. So you could use different letters just so you guys know. You can use g of x, h of x, j of x, anything you want to. They're just different wedding rings, but they all mean the same function. Okay? So, now let me tell you something that's a little bit scandalous about functions, though. Mr. Y has to keep his promises. So whenever she chooses to be a certain number, he has to be a certain number as a response. But it doesn't work the other way. In other words, she doesn't make that kind of a promise. Let me give you an example. This symbol right here, if I gave you x squared equals y, if I told you that she said, today I'm going to be a 4, what does he have to be? He would have to be 16 if he's going to be faithful to his promise. Okay? But it doesn't work the other way. She doesn't have to keep her promises. I know. It doesn't seem fair, but that's how it is in the world of math. So, let's say that one day he decides, I'm not gonna base what I do on her. I'm gonna do me today. Today I'm gonna be 16. What? Okay, so she's gonna do her best to try to serve him, and like, okay, I'll try. But let's see. What is it gonna come out to be? 4. Yeah. But does anybody know she can also be something else? -4. Because -4 squared is also 16. So here's my point. Once again, leave the story behind. For every number you plug in for x, you should only get one number for y. But it doesn't work the other way. If you plug a number in for y, you can get 2 different answers for x. That's still a functional relationship. So, and that's because y is not supposed to be the input. X is supposed to be the input. So let's go ahead and look at an example here. So objective 1's been accomplished. I said today we're going to talk about what is a function. All right. So someone want to bonus point? How would you describe what a function is in your own words? I know you could probably read it right off the paper, but if I were to ask you what's a function, would someone want to tell me what you think a function is? It's a relationship. It sure is. It's a relationship between what? There you go. Between 2 variables, x and y. Okay. And there's an important part to that relationship. For every x, we should have 1 y. That's it. So those are the 2 big pieces of what it means to be a function. All right. So there's our first objective. What is a function, and what's the notation? F parentheses x goes where the y is at. So those are 2 intros there. Now we're going to move into our second objective. Our second objective today is you should be able to look at some tables or a graph and tell me, is that a functional relationship? Is it a function or not? Well, here's how you can tell. Every x should have only 1 y with it. So for instance, this x here, it has 1 y with it, it's -2. This x value here has 1 answer. This x value has 1 y value with it. This x value has 1 y value that goes with it. So it looks to me like every x value has 1 y value. So we'll put since every x has only 1 y with it, yes, this is a function. In other words, if Miss X feels like she's 8 that day, Mr. Y is going to be 8. If Miss X feels like she's 3, you know for sure Mr. Y is going to be -2. He's not going to be unpredictable. We'll know exactly what he's going to be. Let's look at the next one. So if X is 3, then Y is 6, right? If X is 2, Y is -3. But there's a 2 written there again. 2 is also -6. So when Miss X is 2, it looks like her husband's unpredictable. We don't know what he's going to be. That's not a functional relationship. So we're going to say, since X equals 2 has 2 different outputs, the answer is no. The answer is no. It's not a function. Now I'm going to give you guys an easier way to tell this now, okay? The easier way is this. Do you see any repeating numbers here in the X table? No. No. So since there's no repeat, that means each one of these X's are giving me one answer only. Do you see repeats here? Yeah. Since there's a repeat, because of that, that number is getting matched up with 2 different Y values, and that's not okay. So you can't, no repeats are allowed.
I have a question.
Yeah.
So what if there was repeats on both sides? Like if the second -2 equals -3 as well?
Oh, so if this was -3 also?
Yeah.
Then let's go back to the story. If I told you she was X, what's he?
Y.
Well, what number would he be? If I had this, what would he be? I said she's 2, he's -3. Or negative, either way, no matter what, when she's 2, he's -3, so that's functional. But if I have it like this, I don't know what he's going to be when she's 2. I can't predict. So you should be able to predict what Y is based on the X. All right, so let's take a look at the next one. Now, do you guys see any repeats on this in the X column here? No. So this is a function, okay? That's a function. Now, some of you guys might be seeing something, though. Do you guys see the funny thing up there?
Yeah.
We do have repeats over here, but that's okay. Remember I told you if he's the input, she could have 2 different outputs. That's fine. So you can have repeats over here. So repeats over here are okay. So let me explain it in the original way I was explaining it, though, just to kind of connect everything together. Every X should have only one Y with it. So if I pick -5, what's the Y? Okay, so that X has one answer with it. If I say X equals -3, what's the Y? That X has only one Y. I understand it's sharing the Y, but it doesn't matter. It has only one Y with it. Okay? So we just can't have this kind of thing going on there. All right? So that's how you could tell by looking at a table if something is a function or not. Now you might be wondering, who cares? Why do mathematicians care if something's a function or not? Well, I've been kind of suggesting a little bit. There's some predictability. You know, here, if I tell you what X is, you can predict what Y is going to be. Right here, if I tell you what X is, you're not sure sometimes. Okay, so there's unpredictableness, and that's not fun in math. You don't want things to be unpredictable. But also, functions are a whole group of equations, and there's a whole bunch of math that you could do with functions that you can't do with other types of things. So we're not going to get into what that is right now, but the point is it's a type of thing, and there's rules that go with those types of things. So you want to know which is which. Okay, so that's why mathematicians care about that. All right, so here's 2 for you. I want you guys to see which of those are functions, yes or no. There's our answers. And let's go ahead and take a look at another one here. How to tell if a graph represents a function. So a graph, you guys, is just another way to represent a function. Those tables we just saw, those are just points. Okay. Like, for instance, I could graph these. I'll show you. I don't want you guys to do this, but I just want you to watch. I could go over 4, down 2. That's this point. Over 1, up 1. That's this point. 0, 0. That's this point. Over 4, up 2. And there's my graph. So I could graph these things. So tables and graphs are just two different sides of the same thing. Okay. Now, how can you tell if something's a function, though, by looking at a graph? You guys remember it was the 4 that caused the problem? Okay. Well, let's take a look at those 2 points. One's here, one's here. They're right on top of each other. On a graph, when that happens, that means it's not a function. And what we do is we use this thing called the vertical line test. If you can draw a vertical line and it touches the graph twice, that's not a function. So if you can draw a vertical line and it touches it, horizontal, no. That's okay horizontally. Because notice here, at this vertical line, I drew that at x equals 4, right? And what that shows me is that there's 2 places where x equals 4, but there's 2 different y values with that 4. And because of that, this input has 2 different outputs. And so that's not a function. So we call that the vertical line test. Okay? So let's apply that here. You might want to write a little note over here. We'll call it, matter of fact, I wonder if it's on the next slide. Let me see. It might be. No, it's not. So we'll write it down. Write this down on your notes. Vertical line test. And you do this one with graphs. Okay? So vertical line test. If a vertical line, which by the way is that, up and down. If a vertical line touches the curve more than once, it's not a function. If it touches it more than once, then that means that input has 2 different outputs, and that's not a function anymore. Okay? So, for number 1, if I draw a vertical line here, how many times does it touch it? Here? Here? No matter where I draw it, it keeps touching it only once. So is this a function? Yes, it is. Let's take a look at this one. If I draw a vertical line here, how many times does it touch it?
Twice.
Is that a function?
No.
Not a function. Now I want you to understand, I can draw a line that touches this graph only once. I could draw one right here. But that doesn't matter. The point is there any place that you could draw a vertical line that touches it twice? If the answer is yes, then it's not a function. Yeah. My blue, so I'm asking, is the red line touching the blue line twice? Yeah. All right, so that's called the vertical line test. A little bit easier, makes a little bit more sense than the table. But so that's our second objective today. Is can you tell by looking at a table, and can you tell by looking at a graph that you're looking at a function? Okay. So let's practice this one a little bit. Can I erase? Any objections? Yes.
So when you're touching twice, so it means that the y answer is the result of the square root?
That's a good question. So it could be. In this case, it is. But there's other kinds of functions that will give 2 answers also. But yeah, there's different kinds of functions that will do that. All right, so let's do this one. I'll give you a second to try that one. Tell me, are those functions or not using the vertical line test? some of it. I'm going to call on you to share out in a second. Here. I have to come back to her sometime. All right, Denise, what do you think about the first one? Yes or no?
No.
The answer is no, it's not a function because if I draw a vertical line there, it touches it 3 times. So for this value of x, matter of fact, let me draw it a little bit differently. If I draw a line right here, that's where x equals 1, right?
Yeah.
For that value of x, there are 3 different y values. So that input is giving me way too many outputs to be considered a function. Each input should only have 1 output. So the answer is no, it fails the vertical line test. Let's go ahead and take a look at the next one. Azalea, what'd you get for this one? Didn't do that one. Let's see. Crystal, what would you get for that one? It is a function. Because no matter where you draw it, it only touches it once. So that's a yes. That's a yes. All right. So we've accomplished our objectives so far. So I'm going to call on you and ask you a question. Ready? My first question is going to Natalie. What's a function? It's a relationship. And Jeremiah's not here. Adrian, it's a relationship between what? X and Y. And it's a special kind of relationship where for each x, Adrian, a function is a relationship between x and y, where for each x I should have only one y. Only one y. Shouldn't have 2 y's, only one. For each x I plug in, I should only have 1. Now our second objective was how to look at a table or a graph and see if it's a function. Kevin, when you're looking at a table, how can you tell if it's a function or not? A table is this one right here. Let me back up a little bit. How did we know when we were looking at a table if it was a function or not? There we go. If the x variable doesn't repeat. The y's can repeat, but if the x doesn't repeat, then we're good. And then, Niana, how can we tell when looking at a graph if it's a function or not? Okay, so it has something to do with drawing a line, right? And we call that the vertical line test. And if it touches it more than once, it's not a function. Okay. All right, so second objective down. Let's move into our third and fourth objective for the day, which is evaluating and solving functions. So we've seen functions as tables. We've seen functions as graphs today. Now we're going to look at functions as equations. Okay, so here we go. Evaluate each function. So for these problems, basically, I give you a function. There's the wedding ring, so I know this is a function. But that's really just a y value, just so you know. You don't need to write this, but I just want to show you that you could think of that as a y value. Okay. And here's the promise that this y value has made to this x. Kind of sad if we're calling her his x because they're married.
Oh,
All right. So here's the promise that he's made. He's promised to be whatever she is times 4 plus 3. All right. So, and what we're going to do now is when you see this, this is what we call evaluating. Okay, and it basically means you're going to take this number in here and you're going to plug it in for x. Okay, so let's do that. I'm going to plug 2 in for x. And since I did it on the left, I'm going to plug it in on the other side also, like that. So basically just replace, and I would highly encourage you guys to write this. I know it seems stupid, but on the next slide I'm going to write something that's like it, but a little bit different, and it'll be helpful. So for here, replace x with the number. All right? And after that, you just simplify. So here we go. P of 2 equals 4 times 2 is 8. 8 plus 3 is 11. And there's my answer. We're going to put a box around it. And we're done. Okay? So evaluating means that you're going to replace the x with whatever number they gave you there in the parentheses. It does. Thank you. Yeah. So she asked a great question. Does this mean that y equals 11? The answer is yes. That's what that means. So let's write that. This means y equals 11 because y is the p of x. That's just the wedding ring that's covering up the y, but that's really y, just so you know. So here's the promise. When she's 2, he's 11. He kept his promise. Quadrupled it, plus 3. All right. So replace the x with the number and simplify. Let's take a look at the next one. H of x equals this. So step 1 is to replace the x with what number? And I would encourage you to start with some parentheses and fill in the parentheses. The parentheses really help us whenever it comes to our order of operations and also dealing with negatives. Having those in there is really helpful. I did it also back when we did slope. Remember y2 minus y1 over x2 minus x1, I said put parentheses. Usually when we're plugging things in, I highly encourage using parentheses. Yeah.
Do we square it first or do we multiply?
Good question. Yes. So PEMDAS, right? So the P stands for parentheses. But what that P means is anything inside the parentheses. Can I simplify -3? No. So I'm going to skip the P step. The next step is E, PEMDAS. E stands for, so we do the exponent. Here's the biggest mistake I see people do with these, is they treat math like reading. And it's different. With reading, we go from left to right in our culture, right? So you might be tempted to do 2 times -3 and then square it, but that's wrong. You don't go from left to right. In math, you do exponents first. So let's put a box around that. What's -3 to the second power?
9.
It's
No.
positive 9.
Yeah.
-3 to the second power, that means -3 times -3. That's 9. So exponents first. Make a little note to yourself. If you have exponents. Exponents before multiplication. I didn't have exponents up here, so that didn't matter. But here we got exponents. So exponents before multiplication. All right. So now we're going to do multiplication. What is what is 2 times 9? And you can think of this like a -1. What's a -1 times a -3? +3. And then you just add from left to right. 18 plus 3 is 21. Plus 4 is 25. So there's my answer. I'm out of space, so I'll write it over here. But I got h of -3 is 25. Okay. This one? Sorry. Exponents before multiplication. Exponents before multiplication. All right. Another little note to you. Maybe you want to write this down. I don't know. Has any of you guys been wondering, like, Mr. Bailey, this is -3 times h. Why don't you divide -3 and solve for h? Have you guys been wondering that? Okay. Because it's not multiplication. It looks like it, unfortunately. This is bad notation in my opinion, because it's confusing. But this does not mean -3 times h. This is a wedding ring. This is saying I have a function, and I'm plugging -3 into it. So this is not a multiplication, so you're not going to divide by 3 and solve for h. It doesn't work that way. So you'll notice I just left it just like that. Same thing here. You don't, when you're doing functions, that does not mean something times something. That's just a wedding ring saying this is a function, and we're plugging something into it. All right, so you guys get to practice, of course. All right, so there's our answers, and we got one more thing we're going to look at today. It's kind of similar to this, but it's a little bit different. What we're going to do is, we're not evaluating here. You might want to underline that word. We're solving. Okay? So evaluating is where you plug a number in for x and you simplify. That's what we just did here. Okay. Solving is where you're going to figure out what the x is. Okay. With these ones, I gave you the input and you found the output. Here I'm giving you the output and you're going to find the input. So here's my function. F of x equals 5x minus 3. Notice the difference here. It says f of x equals 10. It doesn't say this, does it? Don't write this. It doesn't say this, does it? That's different. That means plug 10 in for x, but that's not what we're doing right now. This one says f of x equals 10, and they want me to figure out what would go in here to make the 10. Okay? So here's how this one works. Remember how I told you to write that sentence a little bit earlier? Here's the sentence I'd write here. Last time we wrote the sentence that said replace x with the number. This time I'm going to make a slight change. Replace not x, but replace f of x with the number. Okay? So I'm going to take this entire thing here, the whole wedding ring. I'm going to get rid of it, and what am I going to put there instead? 10. And then after that, we're going to solve. So, how do I solve this? Just shout it out. What do I do first?
Plus the 3.
Plus the 3.
And then divide by 5.
And then we divide by 5. So I get x equals 13 fifths. So this is different. We're not plugging something in for x. We're finding out what x is because I'm giving you the output instead. All right. So here's my function. And this time I'm telling you that y of p equals 5. So see if you could write down the first step for this on your paper. What would I write first? Just write it on your paper there, and then we'll see. I'll give you a second, and we'll see if you got it right. Lily, what did you write first? You didn't do it. Okay. All right. Let's see if Alonzo, what did you write? Maya, what did you write? That would be the first step, is to replace the y of p with the number 5. Now we get to solve it. So what's the first step, guys? Multiply both sides by 3 to get rid of that fraction on the bottom. And now what?
Add the 2.
Add the 2. And we end up with p equals 17. And that's that. So that's our final objective, evaluating and solving. We did evaluating last time. Let's do the solving practice here. You guys can do student practice number 4 on your papers there. And then we'll find someone else to do the second. Can I erase the note? Replace f of x with the number. That's what this is. F parentheses x. This will be our last one? Yeah. It's a little
The
different.
order.
Yeah, I can see. I think the difference is on that one, they both had a 3 on the bottom. On this one, the 2 is only
Like, sorry, PEMDAS for like the first problems you did, you do it in order, but like for like these problems, you do it in reverse.
Yeah,
Okay.
kind of, yeah. Because it's, yeah, it is different.
Okay.
Yeah, PEMDAS is simplifying, so.
Oh, okay. I can do that when you do a class. My study on.
We turned it in on Google.
Yeah.
So what I saw in Google Classroom, I had like 2 So that's why it was 2.
Okay. Well,
I'm sorry.
Yeah.
It has to do with this.
okay.
It's not a big deal. You always do your work. Crystal, could you put your number 2 over there for me? Then Maya, would you put your number 1 up here for us?
Like for those problems?
Yeah.
Or for those?
You're gonna do that one.
Okay.
And then I'm gonna have a Maya do the first one. Then you guys can check your work there.